Okay, so where the video, sorry, pin cap in my mouth, where the video left off the last time was we were just talking about positive and negative charges, okay, and whether force of positive and negative forces. So a negative force means a force of attraction, and a positive force means a force of repulsion. And for a lot of people, that seems backwards. But mathematically, it makes sense because two charges that are the same are going to repel and they're going to give you a positive when you multiply them together. Whereas two charges that are oppositely signed are going to give you a negative charge and they're going to attract. And the way I tell people to remember it is that the rule is made for me. Because if you're a nun, then an attractive force is definitely a negative thing. Okay? So that's how you can remember it. For those of you that are in relationships, if you feel an attractive force to someone else, definitely a negative thing. Okay? So positive is a repelling force. All right, so I want you to now stop the video and try the questions on page, what page is that? 638, numbers 1 to 5. And then once you've tried them, come back to the video because then I'll do them here for you, okay? So I'm not going to stop the video. I'm going to do them right now. But you should stop the video so that you can try them before you see me do them. All right, so the first question says, calculate the electrostatic force between charges of -2 mu c and positive, 2.4 mu c and positive 5.3 mu c. Placed 58 centimeters apart. Now the mu is, do you know? Microcoulombs. And a micro is times 10 to the 6th. So you're going to do, oops, now I need to come back to my sheet. Sorry. So you're going to do FQ is equal to KQQ over R squared. So FQ is equal to 9 times 10 to the 9th Newton meter squared per coulomb squared. 1K was negative 2.4, and a micro is times 10 to the negative 6 coulombs. The other Q is positive 5 point, I think that's a 3. My book's too far away now, I can't see it. 5.3 times 10 to the negative 6. And then divided by the distance between them is 58 centimeters, which of course you have to change to meters. So 5.8 meters, and then you're going to square it. I am not going to do this in my head. I don't know if that's focused or not. 9 to the 9th times 2.4 to the negative 6 times 5.3 to the negative 6, and then divided by 0.58 squared. And it gives you, so I think I might have typed that in wrong. I'm going to try that again. 9 to the 9th times 2.4 to the negative 6 times 5.3 to the negative 6 divided by 0.58 squared. Oh, it's my calculator that's dying. That's what the problem is. So FQ ends up being a negative 0.3403 newtons. And the negative means it's an attractive force. So just like in all other type of questions, we have to say, what does the negative mean? Okay, so you write beside it that it's an attractive force. All right, next one up, question 2. It says, the electrostatic force of attraction between charges of positive 4 microcoulombs and negative 3 microcoulombs is 1.7 times 10 to the negative 1 newtons. What is the distance? So this time you're doing FQ is equal to KQQ over R squared, but you're rearranging for R squared. So it's going to be KQQ over FQ. So R squared is going to be equal to 9 times 10 to the 9th Newton meters squared per coulomb squared. One charge was positive 4 microcoulombs, so 4 times 10 to the negative 6. The other one is negative 3 microcoulombs, so negative 3 times 10 to the negative 6. And then over the force. And the force is 1.7 to the negative 1. But it says it's an attractive force. And we've already talked about the fact that attractive forces are negative. So you have to put a negative on here. If you didn't put a negative on, you'd end up with an r squared equal to a negative value, and then you'd have to take the square root of a negative value, and your calculator would be very unhappy. Okay, so it's not going to put the negative on for you, the book or me. You have to realize, oh, attractive force, that means that it's negative. So now you punch in 9 to the 9th times 4 to the negative 6 times 3 to the negative 6, and that's a negative, divided by negative 1.7 to the negative 1. And I think, oh, yeah, and then you take the square root. And I think you get, if assuming I typed it in right, 0.797 meters. Okay? You can tell I'm not used to using a calculator. I really stink at it. 4 to the 6. I could almost do this one in my head, actually. And then divide it by 0.17. Square root. Yeah, I think that's right. Okay? So these are really pretty easy. No big deals. There's 1, there's 2. Number 3, 2 identical charged objects exert a force on each other of 20. 2 times 10 to the negative 2 newtons when they are placed 34 centimeters apart. What is the magnitude of the charge this time? So this time you're looking for the Q. So we know FQ is equal to KQQ over R squared. And this time you're looking for the Q, and they're identically charged, so you could write it as KQ squared over R squared, and then rearrange for Q. So Q squared is equal to R squared times the F divided by the K. And then just fill your numbers in. Okay, so try the others of these. That's probably enough of these. Oh no, I still have another 2 minutes, so I can keep going. So if we do this, what was the R? 0.34 centimeters, and that's squared, times 2 to the negative 2, and then divide by 9 to the 9th, and then that's Q squared, so take the square root, and you get, for Q, after you take the square root, 5.07 times 10 to the 1, 2, 3, 4, 5, 6, I think it's 7. My calculator is using, yeah, it's 7. And it's really 5.068 times 10 to the negative 7 coulombs. Okay? And that is a negative, but it's hard to hold the paper and write neatly. So 10 to the negative 7. I hope you appreciate I'm writing backhand here. Okay. Number 4. 2 oppositely charged objects exert a force of attraction. Remember, traction's going to be negative, of 8 newtons on each other. What will be the new force of attraction if the objects are moved to a distance 4 times their original distance of separation? You don't actually even have to use numbers this time. So you can do FQ is equal to KQQ over R squared, and it says that it's going to be 8 newtons. Okay, so it's equal to 8 newtons. And now it says we're going to move them a distance 4 times bigger. If R gets 4 times bigger, and R gets squared, that means the bottom is going to be 16 times bigger than it was, which means that the force should be 16 times smaller than it was. So 1/16 of 8, what is 1/16 of 8? Have you answered yet? So do 8 times 1 over 16, and you should get a half a newton. Okay? So if you make R 4 times as big, and that gets squared, then the F should get 16 times smaller, or be a half. Number 5, 2